Good morning. We have to see about an MT8591 sensor and the instrumentation. Okay. So actually, before going into the subject, we have to know what is the meaning of sensor and what is the meaning of an instrumentation. What is sensor? The sensor which converts stimuli such as light, heat, sound, and motion into electrical signals. Okay. It converts stimuli such as heat, light, sound, and motion into a electrical signal. So these signals are passed through one interface. These signals will be passed through one interface so that it converts them into a binary code and passes this onto a computer that has to be processed over on it. Okay. So a sensor which converts stimuli into electrical signals. All the signals will be passed through an interface, so that converts them into a binary code, and it passes onto a computer which has to be processed. Okay, so this will be in the case of an sensor. What about in the case of an instrumentation? So what about instrumentation? It is the basic process control in industry. It is the basic process control in industry. So what will be doing over on it? So in industrial control, we'll have a wide number of variables: temperature, flow, level, pressure, and distance, which can be sensed simultaneously. So sensor which converts stimuli into electrical signal, whereas the instrumentation is the basic process control in industry. So what are all the advantages of sensor? So what it does? So actually it is used to accelerate the process. So by that it can able to make them more accurate. Okay. Second one, it will collect the process and assert data in real time. Okay. Third one, it will monitor the process and it asserts accurately, reliably, and continuously. And increase in productivity and reduce the total cost of ownership. And finally, it is for lower energy wastage. So the main advantages began over here to accelerate the process, collect the process, monitor the process. By that, we'll have an increase in productivity and reduction in total cost of ownership. So the first unit, what does it say? Actually, it says about what about the basics of measurement? What are all the classifications of error? What about the error analysis? So we'll be classifying into two different types: static and dynamic characteristics. What about the characteristics of transducers? And what about the performance measures of sensors? How the sensors are classified? What about the sensors calibration techniques? And what about the sensors output signal type? Okay. The textbooks will be referred the measurement systems, application and design by Ernest O. Dublin, and a course in mechanical measurements and instrumentation and control by Sane and Punit Sane. Okay, but the references books are to be the Survey of Instrumentation and Measurement by Sujata, and Sensors in Manufacturing by Hans-Kurt Tonschoff. Will be using of an instrumentation for engineers and scientists by John Turner and Martin Hill, whereas Padranabas for sensors and transducers and industrial communication technology, Richard and Dorothy. By using of this text and reference book, so actually it helps to cover the analysis syllabus. Okay. So now we have to define what is measurement. What is measurement? Actually, it is defined as describing various phenomena in quantitative terms. We have to define in terms of an quantitative. Okay. So we'll have some quotations for the measurement. What it is? As whatever exists, it has to exist in some values. Whatever exists, it has to exist in some values. Okay. So the measurement of a given quantity is essentially an act. It's essentially an act or result of comparison. It's essentially an act or result of comparison between a quantity whose magnitude is unknown, with a similar quantity whose quantity is known over here. Okay, the measurement of a given quantity is essentially an act or result of comparison between a quantity whose magnitude is unknown with a similar quantity whose quantity is known over here. Actually, it is nothing but the comparison of two quantities. One is to be the unknown quantity and other one to be the known quantity. And what we have to remember that the measurement expresses the result in a numerical value. It is express the result in a numerical value. Okay. What is the requirement for comparison? Why it's needed? Okay. So the standard used for comparison it must be accurate and it is commonly acceptable by the all. So whatever the standard we are using, so the comparison must be accurate and it has to be commonly acceptable by all. The second one, the standard must be the same character as the measure and the quantity being measured over here. The standard must be the same character as the measure and the quantity being measured. Okay. And when we are saying about the standards, actually it must be defined by some legal or recognized agency line like ISO and ISA, etc. The standards must be defined by some legal or recognized agency like ISO and ISI, etc. Okay. So the apparatus used and the method used for comparison must be provable. So what are all the apparatus used and the method which must be provable? Okay. So these are all this is the requirement for comparison. The next we are need to know what about the significance of measurement. So we'll have a two significant. One is to that design of equipment and processes, and second one proper operation control and maintenance of processes. Okay. Actually, both these functions require measurement. Okay. This is because proper and economical design of equipment and for proper operation control and maintenance of industrial processes which require a feedback of information. Okay. All this information is provided only by the measurement. Okay. So when we are making an design, so we are need of operation control and it is to be the maintenance over on it, and apart from it requires the feedback. Okay. So that is through measurement, the product and the process can be designed with maximum efficiency, with minimum cost, and with a desired degree of maintenance and reliability. So, what are all the methods of measurement? We'll have two different methods. One to be the direct measurement, another one to be the indirect measurement. So, what about direct measurement? Actually, the unknown quantity is directly compared against the standard. Okay, that is the result will be expressed as a numerical number under unit over here. Direct method is common for the measurement of physical quantities like length, mass, and time. So in this method, the human directly made the comparison. So because of the involvement of human factors, the direct method of measurement is not always possible. It is to be the feasible and practical. So the direct method mostly will give an inaccurate result. Okay? So hence direct methods are not preferred and are less commonly used over. Okay? This is the case of an direct measurement. Whereas in the case of an indirect measurement, actually it is used in engineering applications. It uses the direct method of measurement. So in this method, the measurement system consists of a transducing element, so which converts the quantity to be measured into an analog signal. Okay? Then the analog signal is then processed by some intermediate device and is then fed to the end device, which presents the result of the measurement. Okay? So in the indirect method of measurement, it consists of a transducing element. So we know that what is the function of transducer. It converts the quantity to be measured into an analog signal. So we'll be seeing the comparison of methods of measurement. So we'll have a direct method and indirect method. Actually, unknown quantity is being measured by comparing directly with primary or secondary standard. Whereas in the case of an indirect, unknown magnitude is measured by comparing with the standard indirectly through the use of a calibrated system. Okay, so this will be case in the case of an indirect and direct measurement. So whereas in the case of here, human senses are very much necessary for direct measurement. Whereas in the case of an indirect, actually it consists of a chain of devices which form a measuring system. Okay. What about the result? The result obtained from direct measurement or direct comparison are not that dependable. Okay. But in the case of an indirect, it consists of a detector element to detect the transducer, and a unit to indicate or record the process signal. Okay. So this is about the direct and indirect, and it is not always accurate. Different direct measurement is not always accurate. Whereas in the case of an indirect measurement, it have a fairly accurate value. So see over here, what are all the instruments we'll be using over there? We'll be using of an scale, or we'll be using of an measuring tape. Okay, we'll be using of an vernier caliper. So this is will be used for the direct measurement. Whereas the case of an indirect measurement, actually it is to be the fairly accurate. Actually, it consists of a chain of devices. So by having about an meter element over there. Okay. The next one to be the what are all the modes of measurement. So based upon the number of conversions, the basic categories of measurement have been developed over here. So they are to be named as the primary measurement, secondary measurement, and third one to be the tertiary measurement. Okay. So let me see one by one. What about the primary measurement? Actually, it involves direct comparison and direct observation. So there is not involvement of any conversions over there. Okay. So we doesn't have any conversions. Just we'll have a direct measurement, direct observation by using of your scale or by using of a measuring scale. Okay. For example, we can able to measure length, height, depth, or width. So it does not involve any conversion over here, and we will have a direct observation. Okay. The next one to be the secondary measurement. So here this will be given for an indirect measurement over here. So indirect it involves one conversion or will have a two conversion. Will have a one conversion or to be a two conversions takes place in the case of an secondary and tertiary. So whereas in the case of an secondary, we'll have only one conversion. So see the examples which is given here, temperature measurement. The first thing we'll be having of here input signal, that is to be the temperature, that is to be the primary signal, which is given to the thermometer. So the first conversion, that is the primary signal, will be converted into an secondary signal. That is, we'll be having of one capillary rise over on it. So the observers will observe the function. So involvement of one conversion takes place in the case of an secondary measurement. Whereas in the case of an tertiary measurement, actually there will be a two conversion. Okay. So in the case of a two conversion, we'll have a rotating shaft. That is, we'll have a shaft speed. That is to the primary signal. So the primary signal will be converted into an secondary signal. So we'll have a first conversion. So the shaft speed will be converted into an eddy current with the help of an permanent magnet and aluminium cup. Okay. So then after that, the secondary signal will be converted into a tertiary signal. So the thing over here to be converted into an aluminium cup and a spring pointer. So we'll have a pointer rotation. Okay. So we'll have a involvement of two conversions, which means of an tertiary. So that the best example what we are seeing over here to be the rotating shaft over here. So these are all the introduction about and what is measurement and what about the modes of measurement and what about the types of measurement seen over here. Okay. So apart from that, actually we'll have a different types of instruments. What are all the different types? Actually, we'll have three different types. One to be the mechanical, second one to be the electrical, and third one to be the electronic. Okay. So what we'll be seeing in the case of a mechanical, actually it was the first instrument in nature and the principles on which they are worked are given today. Advantages when we are seeing over it, actually it is very reliable for static and stable operation. But the disadvantage for mechanical, actually it is unable to respond rapidly to the measurement over here. Okay. And these instruments are potential source of noise and hence cause pollution of silence. And when you are saying about an electrical measurement, actually these instruments is indicating the output of detector than mechanical instruments. Unfortunately, electrical instruments have to depend on mechanical instrument as an indicating instrument or an device over there. Okay, since mechanical instruments have some inertia and they have limited time and hence frequency response over it. The next the thing we have to see about an electronic instrument, actually this requirement to step up response time and also the direction for dynamic changes in certain parameters which requires the monitoring time of the order of milliseconds and quite often microseconds, which have led to the development of electronic instruments. So what are all the advantages behind when we are using of an electronic instrument? Actually, we'll have a more reliable, lightweight, compact, very fast response. Power consumption is very low over here. Okay. And disadvantage for the electronics, actually it is a high cost and it is to be the complex circuit over here. Okay. And apart from that, the classification will have a absolute instrument, secondary instruments. So absolute will be saying about an galvanometer or a railer. Whereas in the case of a secondary instrument, we'll have a voltmeter, ammeter, thermometer, a pressure gauge. Okay, and then the instrument classifications according to their functions, we can able to know about an indicating, recording, controlling. Whereas indicating, which indicate the magnitude of the quantity. So any example of an indicating measurement can go for voltmeter or ammeter, which indicate the voltage value or the current value. But the recording, actually, they will be giving the continuous record of the quantity being measured over a specific period of time. So example, we'll be using about an X-ray recorder. Whereas in the case of an controlling instrument, the instrument is used by the instruments to control the original measured quantity. So just the example, we can go for a thermostat or temperature control. So that's why overall the introduction to the measurement has